Inspired by the research of Dr. Kim Holland on tuna thermoregulation and Dr. Ethan Mann on antimicrobial properties of shark skin, we have created IncuMat, a sensing heat mat that regulates babies' temperatures in place of an incubator at a low cost and to be used in any location. The inspiration for our shark skin micropattern comes from an article by Dr. Ethan Mann at the Biomed Center. Dr. Mann hypothesized that the shark skin micropattern is an effective tool for reducing bacterial load on surfaces without toxic additives. Dr. Mann tests the hypothesis by introducing the micropattern in a smooth control to two different strains of bacteria, MSSA and MRSA. In his first test, he sprayed the strains of bacteria on the surfaces to achieve even loading. In his second test, he completely submerged the surfaces and plates with the bacteria for 1 hour. In his third test, he cut the test and control surfaces in semicircles and laid them beside each other in petri dishes. For his final test, he ran the test and control through all the forms of bacterial contamination before measurement. The results were surprising. Bacterial attachment and persistence was reduced 99% when comparing the micropattern to the smooth surface. In addition, the micropattern reduced 87% of the bacterial transfer when compared to the smooth surface. In conclusion, the shark skin micropattern is an effective and attractive method to broadly reduce microbial contamination on surfaces without the use of an antimicrobial agent. When adopted into real-world use, the application of the shark skin micropattern onto high-touch surfaces is expected to limit bacterial contamination. The primary biological inspiration utilized by the IncuMat is the thermoregulatory abilities of tuna fish. Tuna fish are able to ensure that their internal temperatures remain stable by limiting the fluctuation of their body heat. This function is translated into the IncuMat, as the mat maintains the baby at a constant temperature and ensures external heat does not deviate too far from the average temperature. Both tuna fish and the IncuMat work through temperature sensors. The IncuMat ensures that the baby's heart is not beating too fast, causing overheating, and that the baby isn't sweating too much, which would cause excessive cooling. The sizes used to test tuna fish thermoregulation are accurately translated to the small size of the mat, intended for infant use. With a shark skin texture covering the entire mat, the structure of the mat effectively imitates the antimicrobial properties of real shark skin in preventing bacteria from forming film and growing. Though the IncuMat closely mimics the characteristics of both tuna and shark skin, it is limited in its operating environment and functionality. While the tuna fish were tested in submerged, controlled environments, the IncuMat, when used commercially, will be exposed to various temperatures out in open air. Additionally, tuna fish use their thermoregulation to spread heat throughout their entire bodies, while the IncuMat focuses on applying heat to just one side of the baby. Tuna fish have their own internal heat sensors, but to find an accurate and effective temperature sensor for the baby will be difficult. Nonetheless, the biological inspiration we have based the IncuMat off of shares the same key distinguishing characteristics as the mat. In order to pursue this design on a larger scale, the first step would be to run tests on the original prototype in order to improve its efficiency and functionality. After testing the product in various environments and on various human-like temperatures, it would be helpful to collaborate with a series of engineers who could assist in the programming of the device, as well as various scientists to ensure that the thermoregulation is safe and fully operational. These collaborations could confirm the functional aspect of the product, as well as ensure its long-lasting use. Additionally, collaborating with designers could be useful in order to improve the quality and durability of the product. Here, because the final design would need to be accessible and portable, developing a system that is light as well as compressible, flexible, and easy to use would be a goal for the designers involved in developing the final product. Additionally, because the product should be affordable, it would be helpful to collaborate with investors and search for individuals willing to provide various resources for the cause in order to lower the final cost of the product for consumers. These resources could include a donation or discount on the physical materials involved in constructing the product, as well as financial contributions to fund the project. If these kinds of resources were provided for the project, it could be possible to reduce the final cost of the product in order to ensure its affordability and accessibility to the groups that are in need of this kind of medical equipment. This is the heating pad that is used to maintain the infant's body temperature. 3 heating pads will be spread throughout the mat to spread heat all throughout the infant's body. A temperature sensor will monitor the infant's body temperature. If the infant is too cold, the heating pad will turn on. If the infant is too warm, the heating pad will turn off. The temperature modulation will ensure that the infant's body temperature remains between 36 and 37 degrees Celsius. A green LED lights up when the heater is on, and a red LED signifies that the heater is off. IncuMed is a game-changing device for the healthcare industry. With its portability and effectiveness in thermoregulating babies' temperatures, it is perfect for families and hospitals in third world countries to use in place of an incubator, costing only hundreds compared to thousands of dollars. The IncuMed is designed in the form of a mat, enabling it to be easily rolled up and transported to wherever needed. It utilizes the thermoregulating system of tuna fish, which are able to maintain a stable internal temperature despite traveling across vastly varying environmental temperatures. The compact size of the device also enables families to keep one in their own homes, allowing them to continue monitoring the baby without hospital fees. Additionally, the antimicrobial shark skin-like surface of the IncuMat ensures that no matter what the environment is, the IncuMat will remain clean and sanitary, providing a safe surface for the baby to rest on. The clear LED display allows for easy readability for constant monitoring of the baby's vital signs and will automatically alert the parents of doctors if anything goes awry. The IncuMat is meant to save hundreds of lives by giving families in third world countries access to the care their newborn children need anywhere they are without the high costs of hospital fees.